Hello and welcome to another Let's Study video on programming principles and practice using C++, 3rd edition. Today we'll be going through and working through the drill section of chapter 4 at the end of chapter 4. Here we have. And due to where the text is, it's a little difficult because the camera is literally bolted to the ceiling. So instead I took a picture of it, and now I can just have that picture up and I can move the book elsewhere, and I can have my keyboard in a comfortable location so that I can actually, write some code. Still got the camera right in the middle of my face, though, blocking my view of the of the computer. But I see no way around that from here on out into the future. So what we have is we have the drill. Go through this drill step by step. Do not try to speed up by skipping steps. Test each step by entering at least 3 pairs of values. More values would be better. Okay? So, step 1, write a program that consists of a while loop that, each time around the loop, reads in 2 ints and then prints them. Exit the program when a terminating vertical bar is entered. Okay? So I'll put that down. Let's open up Visual Studio 2022 Community Edition. We're going to create a new project to answer this drill, or to go through this drill. We want to do an empty C++ project. We're going to name it PPP3 underscore chapter 3 abbreviated and drill. And leave everything else default. Let me bring up the project that we just asked it to generate. We go to source files, we right click, add, new item. We want a main.cpp, which will, as far as I haven't finished the drill, but I believe that all of the code will end up just in main. That will be our structure, just one source file. And then if we right-click project property, right-click the project, and then go to properties, and go to C/C++, and then looks like we already have this available. We want that scan sources for module dependencies. We want to bring that back down to yes. If we go to language, we want to change the language standard for C++ to the latest, and then this flag here to build the ISO C++ standard library, we want to hit yes on that as well. We apply these changes, we hit OK, and then, well, we can just get right on it. So I'll bring up the drill again for just a moment. So, step 1, write a program that consists of a while loop that, each time around the loop, reads in 2 ints and then prints them. Exit the program when a terminating vertical bar is entered. Okay? So, this program completes chapter 3's drill. So we obviously will need to import the standard library module, and for time saving we'll use the namespace std, and we will need a main function, as every C++ program needs one. At least needs one to be compilable into an executable. We obviously still always want to return 0 on good output, or good successful process. And so to answer the question, we need two ints. So let's int value 1 and int value 2. And then we have a while loop, which we need to get the we need to prompt the user to provide us values. And then we need to get these values. So we can use cn to get value 1. And we can use cn again to get value 2. And then to finish the question, we need to output value 1 and 2. And I'll space delimit them, or separate them with a space. Okay. So this expression, cn, get from cn into value 1, this will always be true, otherwise known as non-zero, if we get a valid number. And I'll write a comment here. Cn fail if when provided with the vertical bar. So I believe this answers all of question 1. Let's bring up question 1. Write a program that consists of a while loop that each time around the loop reads 2 ints and then prints them. Exit the program when a terminating vertical bar is entered. Alright, let's compile this and run it. Give it a shot. Alright, so let's give it the value 1 and 2, and it prints them out. If we give it just 1, it'll wait for another one, and it'll print both. Oh, it looks like it closed. I wonder why. Perhaps the value I gave it was too big. Hold on. What is int max? Do we not know what int max is? Huh. Well, I know it's in the limits. .h. There we are. Int max. So let me write that down. I'll just grab a piece of paper. post-it note will do. So 214748367. Let's try this. Just try to enter it. Okay, so that didn't work. 214748367. So that worked. Now, will it fail if I provide 21474836470 and 2? Yes, will fail. So if we provide it with too big of a number, it will exit the program as well. Alright. The more we know. I'll get rid of this value 3. Alright, let's bring up the problem. We now completed 1. Now we can move on to number 2. Change the program to write out the smaller value is, followed by the smaller of the numbers, and the larger value is, followed by the larger value. Okay, that's easy. So, on a new line, let's do this. Value 1 equals value 2 equals just a little better printing because it's okay, well, we don't want to print things yet. We need to check who's bigger. The val 1 is greater. Than val 2. So we're going to compare val 1 and val 2. And then we're going to react in both situations where that statement is true or false. So, print out. No. The larger. Wait. Bring the question back up. Smaller value is. Okay. So let's do it like this. Smaller value is val 1 in this case. And if we put this down here, val 2 would be the other case. Okay. Let's put a comment here. This handles smaller values. Larger and output. Smaller. And if we copy this code, put it down here, change this to larger in all cases, and then flip the sign, I think that will work. Let's give this a shot. 1 and 2. Oh, we got our new line characters. And a space. One, two. Val 1 equals 1, val 2 equals 2. The smaller the value is 1, the larger value is 2. That is correct. Alright. So that answers number 2. So let's bring up to number 3. Augment the program so that it writes the line, the numbers are equal only if they are equal. Okay. So then let's mix these up. Well, we don't want to mix them up. We want... Hold on. Let's reread that. Augment the program so that it writes the line, the numbers are equal only if they are equal. Only if they are equal. I'm going to assume a smarter output is that we're not going to say the smaller value or the larger value when we know that they're equal, because what I could do is this. Whoops. The numbers are equal. And then if I tried this and I gave it 1 and 1, it would say the smaller value is 1 and the larger value is 1 and the numbers are equal. Now it doesn't make sense to say that the value is smaller or larger than itself. So we want to conditionally print that or don't print that, I think. So what I want to do is I'll bring this up here. Remove, we don't want to remove that, we actually want to bring that here and also here. Delete this. So then Anders value logic and output. So if value 1 equals value 2, the numbers are equal. If value 2 is less than value 2, misspoke. If value 1 is less than value 2, the smaller value is value 1, and the larger value is value 2. So we need to change that to value 2. And then the opposite will be true if this is false up here, and the opposite is true. In which case, these are flipped compared to above, and this should work. So if we provide 1 and 1 again, the numbers are equal. If we provide 1 and 2, the smaller value is 1, the larger value is 2. That makes sense. 3 and 1. Smaller value is 1, the larger value is 3. That looks good. Oh, and just to test, if we give it the vertical bar and press enter, it does exit the program. Okay. Alright, let's bring up the problem and move on. So, change the program so that it uses doubles instead of ints. I think this would be our easiest change, because all we actually have to do is change from int to double up here. And because the cn will grab it just the same, well, the operator is defined with cn to grab a double as well as it's defined to grab an integer as we had it before. This input will still fail on a vertical bar, so that's not going to change. Printing it out, we know that cout can print out doubles just fine. The comparative operators equal to and less than are also the same, so nothing should change. And so if we try this and give it 1.0 and 1.0, it still works. 1.23 and 3.21, and that works as well. And if we give it negative numbers, that works as well. Alright. And the vertical bar test succeeds. Alright. So let's move to question 5. Change the program so that it writes out the numbers are almost equal after writing out which is the larger and the smaller if the numbers differ by less than 1%. That's 1 divided by 100. Okay, so then let's figure out how we want to do this. If value 1 minus value 2 alright, so let's create a double value here. Percent difference, and this will be equal to value 1, well, value 2 minus value 1 how do we get this percentage difference? Okay, so I think we need to use the absolute function. The absolute value difference between value 1 and value 2. Okay. Percent difference? Well, it's not really a percent difference. Well, this might be. Hold on. I think this is a lot easier than I'm expecting. So if the absolute value of the difference between the two is less than 1.0 divided by 100. It might just be just that. I don't like this being here. I will add parentheses. This is an int. I don't like integer division. So I will do double, 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 double. So keeping all of these the same, as well as absolute value returns a double. So it's doubles, 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 doubles. So we're only working with doubles, which means there's no conversions, there's no special cases. Of course, there may be some special cases, but We don't have to deal with any sort of conversions or data loss. Okay. So let's print this out. The numbers are almost equal. Alright, so let's give it a go. So 1.01 and 1.00. Ooh. Less than 1 in 100. Oh, because it was equal to. Whoops. So 1.1 and 1.2. No. So why would that fail? Let's give this a go. So calculator. Oh, the scaling has made this huge. Shrink that down. 1.1 minus 1.2 equals -1, which we take the absolute value, so 0.1. Oops. There you go. So I brought up calculator real quick. 1.1 minus 1.2, 0.1. That's what we're working with. And 1 divided by 100 equals this number. Okay, so 0.1 is a lot bigger. It's 10 times bigger than 0.01. So 1.0001 and 1.0000. The numbers are almost equal. Okay, that worked. Alright. Hold on. Say I gave it -1.001 and 1.000. Never mind. Because we would end up with 2.001, which is way bigger than 0.01. Okay. Whoop. So now change the body of the loop so that it reads just one double each time around. Define two variables to keep track of, which is the smallest and which is the largest value you have seen so far. Each time through the loop, write out the value entered. If it's the smallest so far, write out the smallest so far after the number. If it's the largest so far, write the largest so far after the number. Okay, so this is a big amount of change. So reads just one. So value 1. We're going to have a new value. I'm going to call it double current. And we're going to grab that and only that. So please provide a value, so we change our prompt to reflect the change. I'm only going to grab one. Value entered equals the current. And then we need to apply some logic. So if current is less than, okay, so let's change the numbers here. So value 1 will become smallest scene, and I'm going to define it as int max. And largest scene equals int min, and you'll see why in just a second. So if current is less than the smallest scene so far, the smallest scene will now become the current value, will be assigned the current value. And we can apply the same similar logic here. If the current, I'll change it to current value. So I'm just going to highlight all of where current is, Control F, and then search for current. And then drop this arrow down here, and we want to replace. And we'll replace current with current value. Might as well, we have this space. And replace all. Hit X. So now we have this here, so if the current value is greater than the largest scene, then the largest scene will then be set to the current value. Let's just block off this values, well, this logic down here, and run this. So 1, 2, 3, 24 point something. Oh, cool! It even does scientific notation. Nice. Okay. Cool. What was the question? Now change the body of the loop so it reads one double each time around. Done that. Define two variables to keep track of which is the smallest and which is the largest value you have seen so far. We've done that. Each time through the loop, write out the value entered. Done. If it's the smallest so far, write the smallest so far after the number. If it's the largest so far, write the largest so far after the number. Okay, so I'm going to remove this flavor text and just print out the value. And then if we make this change, we're going to print out the smallest so far. We're going to get rid of this new line character up here as well. And down here, the largest so far. And let's string these together. So that we can make sure that we print out the new line character if nothing changes. Because without this, if we enter a value between the smallest and largest value we've seen, it'll just print the value we gave it, and we won't get a new line. And so we would be entering in, when we hit here, we'll be entering in a value on the same line as our current value was printed at. So 1.2. It's the smallest so far. 1.2. It's also the largest so far. 1.3. The largest so far. 0.1. The smallest so far. 9999999. The largest so far. So that makes sense. Do we like the input responding like this? So when we provide it the first time, let's do it like this. So we are going to grab the value for the first time. If we succeed in grabbing this value for the first time, the largest scene, the smallest scene will equal the current value, and the largest scene will also equal the current value. And let's print out a special statement. So we'll print out the current value, and then the special message, the largest and smallest value seen so far. Or let's say the only value seen so far. And then we'll enter the loop. We can get rid of this down here, I think. Let's leave it for later, possibly, because we haven't completed the problem yet. And let's put this while loop in this if. So this will this right here handles the first value given, In which case, this int max, int min situation doesn't matter anymore. Right, let's give this a try. So, 1.2, 1.2, the only value seen so far, and let's try 1.4, the largest. Let's try 1.2 again. Ooh, we got nothing that time. Well, I guess that makes sense. 1.2, 1.2, 3, 1.3. Yeah, that makes sense with the logic beforehand. Okay. So, number 7, add a unit to each double entered, that is, enter values such as 10 centimeters, 20, 2.5 inch, 5 foot, or 3.3 meters. Accept the 4 units cm, m, in, ft. Assume conversion factors. 1 meter equals 100 centimeters. 1 inch equals 2.54 centimeters, and 1 foot equals 12 inches. Read the unit indicator into a string. You may consider 12m with a space between the number and the unit equivalent to 12m without a space. Okay. So then, please provide a value followed by a unit. By a unit, centimeter, inch, foot, meter. Centimeter, inch, foot, meter. And string. Current unit token. Unit selection. Okay. And then let's grab both CN and CN our current unit selection. And then let's check for good input. So we want to switch on this current unit selection. We can't. We can't. A switch statement only works on numerical or enumeration types. That's okay. We can do a nested if-else tree. So if current unit selection equals meter. Okay, so what we can do is we can whoop. Well, actually, yeah, we do want that. Print that out. Oh, I'm missing semicolons all over the place. So, centimeter. Else if current selection equals inch. Copy this again to foot, 4 foot. One more time. Else if this would be for M for meters. And then finally we have the final case where I don't know this output. And so we want to print out unknown unit selected, well, unknown unit provided. We'll print that out. Current unit selection. And then we will return return -1. Let's just return 1. So this return statement here will exit the program main with value 1 for bad input. And so instead of 1 being here as just 1, let's define it up here. Define bad input exit code equal 1. And then we can bring that down here and put that down here. Expected in expression. Well, equals 1, sorry. We want to just forget that equals. Here we go. So bad input exit code is 1. Or let's change that up. Exit code bad input. Okay. Excuse me. Alright, so let's define our conversion factors. So we need a const expression. Double. And let's bring up the thing. 1 meter equals 100 centimeters. So then centimeter to meter equals 100 divided by 1. Const expression double. 2 meters or per meter? Okay. And we want one inch equals 2.5 centimeters. So inch per, well, centimeter per inch equals 2.54 exactly. Then another const expression double. 1 foot equals 12 inches. So inch per foot equals 12.0 for double. So this is a double divided by a double equals a double, 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 double. We're all doubles, very happy. So then, let's print out the, well, that might get difficult. Feet in. Let's give this a go without all this down here. So let's just block comment all that out. Well, we can attempt to. So let's do 1 centimeter. Prints out 1 centimeter. 2 meters. 2 meters. 4 inch. Prints out 4 inches. Okay. Let's getting actually too cold in here, surprisingly. Apparently we're not thinking hard enough. Okay, so what are we doing? So I think this line is good to go. What isn't good to go is, well, it's down here, but we need to, well, we need this logic as well, right here, to come down here. Uncomment out most. of this, but we do need to tab this in. Okay. We need to comment out this down here again. I still think it'll be useful for later, despite not reading ahead. So this logic is now flawed, but do we still need that logic? Let's check the question. Okay. No. Until 9. So we answer question 7. And we move to step 8. Where unknown unit provided, and we handle it gracefully and blow up the program with an error code. And then we're on step 9, which is keep track of the sum of values entered, as well as the smallest and largest, and the number of values entered. When the loop ends, print the smallest, the largest, the number of values, and the sum of values. Note that to keep the sum, you have to decide on a unit to use for that sum. Use meters. Okay, you have to decide, and then it says to use meters. So make the decision. Here's the decision. Okay, I can do that. I think I can leave that problem up there now because of how small we're down to it. So we want to keep this. We want to keep this. We want to keep that. Let's group these together. And then let's do a double sum. And then let's add context. So these are in meters. And then we also want to keep int number of values provided now equals 0, because that actually makes sense at that stage. So if this succeeds all the way down to here, let's increment up the number of values provided. Using the pre-incrementer operator. ++. And we want to bring that down here as well. Whoop. As well, so we want to copy it instead of cutting it. And put that down here in a similar spot. And then we want to take this logic out. Do we? Yeah, we're gonna take it out. No. Well, we wanna. Ooh. Oh, okay. Oh, we gotta get a thinking cap on. I'm cold. Cold and tired. Yes. Turn off the AC entirely. Threw my beanie on. That should heat my noggin up a little bit. Certainly not feeling my best. Okay. Hope I'm not getting sick. Alright, so if the current value is less than the smallest scene, but we don't know what the current value is in meters. So we need to create a new number. So centimeters, inches, feet, meters. So the current value will now equal the current value divided by the centimeter per meter for this one. And this will be the current value divided by inch, well, centimeter per inch, and then centimeter per meter. And then this one will be foot per inch divided by, is it inch per foot? Whoops, we want to flip that around. Do we? No. We can just multiply it instead. So let's copy that logic up here to down here. So we do nothing on a meter input. And so now the current value gets converted by this stage. So then when we check this, we're checking meters against meters. And we don't want to print that out. We just want to keep track of it. And then yeah, we didn't need that. Once we exit the loop, we want to keep track of the sum. Okay. So current value. So here we go. Sum plus equals the current value. So in these lines, we will convert to meters, convert to meters, convert to meters. Because it might not make complete sense when we read this again in the future, if we do. So then we can bring that down as well, this logic. And then we can start to print out when the loop ends. So when the loop ends, we want to print out the smallest value given was meters. And the largest value given is the largest seen. The number of values given was, well, the numbers of values provided, number of values provided. And I think finally, the sum of the values. Sum. We want to go up here and give sum the initial value of 0. So it's initialized correctly. Okay. Oop. So this is incorrect because we haven't converted yet to meters. So we want to bring that down here. Let's clean up the extra line spacing. Good now? Did I break more things? What happened? Cut that. Bring that down here. See out is ambiguous. I think that's gonna go away if I try to build. Close. Oh, come on. Let's just save, close. I think Visual Studio is bugging out. This is reopen it. Yep. As well, IntelliSense is still working. Nope, now it's done. Yeah, it was just bugging out. Such as using the import library. We'll give you. Okay, so I think we're done the test. Oh, my bones. So 1 meter. That's exit. Smallest value given was 1 meter. The largest 1 meter. The number of values given was 1, and the sum of the values was 1. So the sum of the values we want meter down here. That made sense. Something didn't look right about it though. 1.0 enter meter. 1 meter, the only value seen so far. 1.2. 1.3. Oh, interesting. Huh? Hold on. We weren't grabbing the new unit selection. So our while loop was the old value. Here we go. So it was always assuming it was the value we gave it. Also, I don't like it printing out the space, actually, to be honest. And good thing we only put it up here instead of there, 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 and there. I put it up here where it's only once. So now I only have to make 1 edit instead of 4. So 1.23 meters. 1 point... Huh? Why did it still print the space? Ah, because up here. Alright. 1.23 meters. Now, why does it say... Where's a new line here? So print it out with a new line down here. So we want to get rid of this new line character here. And this will only affect the first value provided. Also, actually, wait a minute. We need to get rid of that entire statement here. The only value seen so far, because we're no longer printing value comparisons as we enter values. So 12. Just do 1 inch. Exit. The smallest value was given was 3.94 centimeters, if I'm reading that correctly, which is not correct. So our current value in inches divided by inches per centimeter. I think we got this one wrong right here. It's 1 inch. That is correct now. 2.54 centimeters. Now, is the wording correct though? So let's pull out paint and draw this out. So we have an inch per 1 times centimeter per inch. Inches get crossed out and we end up with centimeters. And then if we do times meter per centimeter, which is the inverse of what we were working with. Okay, that makes sense. Centimeter per inch makes sense. 2.54 centimeters per inch. So these conversion rates make sense. So 100 centimeters per meter, correct. 2.54 centimeters per inch, that's correct. Inches per foot is 12, that is also correct. So these are good. Our logic was what was flawed. Now, is it flawed everywhere? So I think this is good, which means this is good, and this is good. Feet might be wrong. So if I do 1 foot, one foot should be a lot bigger, I think, than 5 centimeters. A lot bigger. Here we are. There we go. So 1 foot. Whoops. Okay, so I do want to go into new line. No, I stand by that. And then I gotta do the same down. Well, I've actually already done the same down there. I just forgot to bring that change up here. I feel like we could have put this in one function so we don't have so much code being effectively in 2 places. Well, exactly being in 2 places. So 1 foot. Good. That looks good. Let's try to give it a negative value. So let's do, well, 1 meter, 2 meter, 3 meter. exit. So the smallest was 1 meter, correct. The largest was 3 meters, correct. The number of values given was 3, correct. And the sum of the values given was 6. So 1 plus 2 equals 3, plus 3 meters equals 6. Correct. All right. I think we did good. Okay. I think that answers 9. So then, number 10. Keep all the values entered converted into meters in a vector. At the end, write out those values. It doesn't explain how it wants to write them out, so well, let's get a vector of doubles going. So we want a vector of type doubles. Just call it values. Whenever we are provided with a value, and after converting it, we want to add it to it. So we will push back the current value here and here. And then at the end of the program, we will write a range for a double x in values. We'll print them out. So values provided equal the set of x meter Oh, it's check input. We want to get our grammar right, so instead of values, we want value provided. I'm going to do the same down here, but instead values. And can do this with, I would like to do a range, but I want to do something special for when it's the first value, or the last value, I should say. So for int I equals 0, I is less than the size of the array. Increment I, and if I is equal to the size of the array minus 1, so this will be if last value so the values not at I double, and this else will handle the rest, where we can comma separate them. So if we provide two inputs, value to size will equal 2. I will start at 0, 1. This will succeed, and then once it gets to 2, which is equal, it will fail, and it won't go out of range. Okay. Let's give this a shot. So 1 meter. All right. The smallest value given was 1 meter. The largest value given was 1 meter. The number of values given was 1. The sum of values given was 1 meter, and the value provided was 1 meter. Okay. So let's give it 1 meter, 2 meter. Smallest value given was 1 meter, correct. The largest value given was 2 meters, correct. The number of values given was 2, correct. The sum of the values given was 3, correct. And the values with an S, the proper plurality was provided. So values provided is equal to, comma separated, list of values provided, 1 meter and 2 meter. Correct. Whee! I'm very happy. Whee! So what happens if I provide 100 centimeter and 1 meter? Ooh, why did it give me so many lines? The smallest value given was 1 meter. The largest value given was 1 meter. The number of values given was 2. The sum of the values was 2. And the values provided was 1 meter and 1 meter. It did the proper conversions. Now, why did it give me 2 lines here? Let's try to figure that out. So 1 centimeter, 1 centimeter. Okay, so it gave me 2. It happened on the second one, so I think it's down here. Right here. Since we're no longer printing it out per line, this doesn't make any sense. None of this does. So doing a little cleanup. There we go. Give this a go. 1.1 meter, 1 meter. Good. I'm happy with that. Okay, so question 10, which we were answering, was keep all the values entered, converted into meters, into a vector. At the end, write out those values. I decided to write them out as a comma separated in bracket set. So bracket notation. Well, set notation within curly brackets, comma separated, and in the order that they were provided. I think that answers very succinctly. It'll just continue on forever on that one line. I think it will fail after a certain number of characters. I think it's like 4,092 characters or something along those lines. Obviously something I'm concerned about, not very much. Alright, the last bit, question 11. Last one of the drill. Before writing out the values from the vector, sort them. They'll make them come out in increasing order. Okay. So, how do we sort? Do we remember how to sort? Let's take the keyboard out of the way. Let's bring back the video camera. And let's look for the sorting in chapter 3. How did we sort? I'm sure okay, it's down here. Language features, sort. Now, how do we use it? Is there an example of sort being used? Ranges, sort. Here we go. So let's give that a go. Ranges, sort, values. All right, now. Oh, it didn't like it. Now, why doesn't it like it? Short function. Should have put a bookmark on that. Section. Language features. So it's 3.7. Go back down here. Ranges, sort, temps. Now, why isn't that working? In this example, In this example, a vector double temps. The range is sort temps. So we're effectively doing the same thing. A vector doubles. Now, why does it break? Ranges sort. Is it a language feature I'm not providing yet? Enable ranges. I think I did that in the past. Let's search online. I don't want to try this. No, let's try it. Begin values. End. Happy with that. Well, it compiled. It complained first. Hold on. Is it just complaining to complain? Oh, whoops. Wait. I think it might just be Visual Studio bugging out again. Save this all, close, reopen it. I'm sorry. Okay. So I think the answer is this is giving an error. But it compiles. Let's see if it works. So 2 meters, 1 meter, 1 and 2. So it works despite providing an error here. So if we look at our output, if we build one up to date, if I change it just a little bit, rebuild. I'm seeing if we get an error during compilation. Nope, it just succeeded. So this is a telesense complaining about something that isn't an issue. Interesting. All right. Well, telesense can be wrong, especially with the newest versions of C++, such as the dangers of working with the latest C++ standard that isn't officially supported. You can see this message at some point. Macro can be converted to const expression. This one, yeah, I guess so. Fine. Use the new way. And it'll still work. All right. I think that concludes the drill section. Okay, so we went from 1 to 11 and we completed them all. Ran into a bug with Visual Studio bugging out twice, and then finally continuously bugging out about ranges with Vector. I'm sure there's something I can do to get rid of that bug, but this completes the drill for Chapter 3, Computation, from Programming Principles and Practice using C++, 3rd edition. In the next video, we'll be covering the review questions and progressing further along in the book. Thank you for watching. Please like the video if you liked it. Put something in the comments if you didn't. If there's something I got wrong or a question you have, put that in the comments as well. And as always, please subscribe for more videos. It's a great motivator to see people watch my videos. I watch the analytics. I check the analytics on how many people are watching, and it's always a pleasure to see hours a day of people watching my videos, and those numbers go up. Makes me very happy. Thank you for watching, and I'll see you guys soon.